So 7/6 is really a shortcut for you. So to warm up for this shortcut, we're going to take a look at a few problems here. Hey, I can move you back, you know? Yeah. So let's start here. Look at this, x plus 4, x minus 4. 5m plus 1, 5m minus 1. 2a plus 3b, 2a minus 3b, okay? We're going to FOIL it to see what happens, but then I'm going to show you something that goes with this. So if you're multiplying these binomials, notice the parts, the terms are the same. The only thing that's different is what? The operation. You're adding or you're subtracting. Will you put that away, please? Thank you. So if we were to FOIL this right now, we would go x squared minus 4x plus 4x minus 16. And look at what happens. A negative 4x plus 4x is just x squared minus 16. Okay? You FOIL the next two, and we'll take a look at what seems to happen. 25m squared minus 1. Is that what you got? So it would have been 5m times 5m. This is probably the most common mistake that happens with FOILing. When people multiply the firsts and there's variables for both of them, they forget to turn it into an m squared. So make sure you're squaring if you do an m times an m. That's m squared. So 25m squared minus 5m plus 5m minus 1. Okay, that means these go away. A negative 5m and a positive 5m is 0. So you get 25m squared minus 1. So what did you get on that third one? 4a squared minus what? 9b squared. Again, it's 2a times 2a, so that's 4a squared, minus 6ab plus 6ab, so those go away, minus 9b squared. Okay, so here's what I want you to see. This and this and this are all differences. When you talk differences in math, that's subtraction, okay? So it is a difference, and then it's called a difference of squares because both parts that you end up with are perfect squares because you're multiplying things by themselves, an x times an x, a 4 times a 4. So this is a perfect square and this is a perfect square. 25m squared is a perfect square, 1 is a perfect square, 4a squared is a perfect square, 9b squared is a perfect square. So these are called the difference of squares. It's subtraction with perfect squares, okay? So when you factor a difference of squares, the first thing you have to do is make sure that you have actual difference of squares. So you have to make sure that you have perfect squares before you just go and assume that this is going to work. Okay, so that's step 1. Step 2 is you use the rule that I'm going to show you to factor it. When you see something that looks like this, a squared, so some perfect square, minus, it has to be minus, some other perfect square, you can just do what we just did here in reverse. So notice when it was a difference of squares, it came from the square root of each. Let me just get rid of this real fast so I can show you what I'm looking at here. Okay, so this was x squared minus 16. If I square root this and square root that, I get x and 4. And if this is a minus sign, then this will be a plus and a minus in my two binomials. Okay, so it's really just a shortcut for you how you factor this. So here's how it goes. If it's a squared minus b squared, then this is a plus b times a minus b. Okay, so it's the reverse of what we just did. You want to come up here and teach this since you know it so well you don't have to listen to me? So you're welcome to if you want. Okay, then how do you check your work on this? you could FOIL it, right? If you FOILed this, first, outside, inside, last, you'd get a squared minus b squared. So you can always check it by FOILing once you've solved, okay? Okay, so take a look at this. If I want you to factor this as a difference of squares, what do you think you're going to end up with? First of all, are these perfect squares? A squared is a perfect square and 4 is a perfect square. I can take the square root of both of them. So your first thing you do when they're both perfect squares, the first thing I do anyway, is I write the two binomials and I write one as a plus and one as a minus because it will always work out that way. Then from there, what I do is I take the square root of the first one and I put it in the first spot, and the square root of the second one and I put it in the second spot. So this is a plus 2 and a minus 2. Okay, square root them both, make one of them plus and one of them minus. Okay, so go to number 3. Is 81 a perfect square? Yeah. You can take the square root of that. Is x squared a perfect square? Yeah. Yes, you can take the square root of that. So write it out. What symbols do you put in between? One plus, one minus, and then what do you do? Square root. We're going to square root 81 and we get 9. Those are going to go in the front. We're going to square root x squared. What's the square root of x squared? It's x. So 9 plus x times 9 minus x. And again, if you want to check it, FOIL. When you FOIL it, it should end up like this, and it does. Okay? Okay, look at number 5. Is this a perfect square? Yes. Is this a perfect square? 25. Yes. Is it a difference of squares? No, it's a sum. Sums don't work. You cannot factor a sum of perfect squares. This is one of those where you just say prime. It's as simple as it can go, and you don't have to do anything to it.
How do you know if a number can be, it's a perfect square?
If it's a number, you could plug it into your calculator, the square root of 81, the square root of 25. Remember how to plug that in? If it's a variable, it needs to be divisible by 2, the exponent. So if it's like a to the 6th, it would become a to the 3rd when you square root it. You're just dividing by 2. So k squared or a squared or x squared is always a perfect square because 2 is divisible by 2. Yeah. Okay, look at number 7. Is 9b squared a perfect square? What would the square root of 9b squared be? 3b. Okay, square root of 9 is 3, square root of b squared is b. Is 100 a perfect square? You can take the square root of that. Is it a difference? Yes, it is subtraction. So you're going to set it up. 1 is a plus, 1 is a minus. This is 3b because we're taking the square root of 9b squared. So 3b and 3b. And then the square root of 100 is 10 and 10. Questions on that? Okay, you try number 11. 11 has 2 variables, so take your time on that one. We're just going to skip over 9. We don't need 9 right now. But see what you do with number 11. All right, who thinks they have it? What'd you get? 2h plus 5g and 2h minus 5g. So square root both. One's plus, one's minus. Okay? So just watch out for those. I feel like when there's a second variable, like the g's there, they often get forgotten.
The plus and minus, they're like interchangeable, right?
Yeah, if you put the minus first and the plus second, that's fine. Yep. Okay. Look at number 13, because 13 is a little bit trickier maybe. Just because the 2 variables are together. Is this a perfect square? X squared, y squared? Yeah, what would it be when you square root that? XY. Is this a perfect square? 1. Yes. A lot of times people forget that 1 is, but 1 times 1 is 1. So it is a square root. it is, you can take the square root. So if we set this up, perfect squares, one's a plus, one's a minus, and like Lincoln said, it doesn't matter if you put the minus first and the plus second, but it can't be both pluses and it can't be both minuses, okay? So square root x squared y squared, you get xy. So that's going to be your first term. Square root 1, and you get 1. So that is your difference of squares. Look at 15. Is 4c squared a perfect square?
Yeah.
Is 5d squared a perfect square? No. If they're not both perfect squares, then you say prime. There's nothing else you can do to that, so you just leave it be.
What if the like the exponent to the variable? Does that matter if it's like able to?
Square rooted?
Yeah.
Yes. It's got to be divisible by 2.
So then you put prime if it can't.
If it's like a 5. If it's an odd number, yes, you would put prime. Okay, look at number 19, because now your exponent is different. Now it's something r to the 6th. So here's what you have to watch for. This is what I was just saying. If your exponent is divisible by 2, you can take the square root of it, okay? When you take the square root, you divide it by 2. So if I said 121 r to the 6th, is that a perfect square? Yes, it is. How about, is 1 a perfect square? Yes. So you're going to set it up 1 plus, 1 minus. What is the square root of 121 r to the 6th? 11 r to the 3rd. So take that 6 and divide it by 2 when you square root it, okay? And then this is 1. So 11 r to the 3rd and 1. 1's plus, 1's minus, and you're done. It's not awful, right? Yeah, Lincoln.
Can't we just take away the 6 because like 1 to the 6th is also just 1?
But this is an r. It's
Oh, yeah,
r
yeah,
to the
yeah.
6th. So, yeah. Okay. The next chunk here is not much different. It's kind of combining what you did yesterday with what we did today. So in these ones, you're going to find the GCF first, take it out, and then set it up as difference of squares. But what ends up happening a lot on this one is people forget that when they take something out, it has to be at the front end of their final answer. So that's where we have to be careful here. Look at number 21. You are looking for, is there a number and or variable that you can factor out of both pieces? 2. You can divide everything by 2. So you're going to pull a 2 out, and then this is a difference of squares. You get 2n squared minus 36 when you divide by 2. And these are perfect squares, and it's a difference. So you set it up like this. One's going to be plus, one's going to be minus. What do you get in your binomials? What's the square root of n squared? N. And what's the square root of 36? 6. So n plus 6 and n minus 6. Just be really, really careful that you don't leave that guy off. Because if you do, your answer's wrong. It doesn't simplify to the same thing. Okay, go over to 24. Is there something that you can factor out before you do the difference of squares? A 5. Anything else? It's what you did yesterday. If I were going to divide both of these by something, some greatest common factor, 5 works, but there's something else. Not a different number.
Oh, 5Q.
Q. There's a Q there, okay? So we're going to factor out, oops, not like that. We're going to factor out a 5Q, which means we're left with 9Q squared, right? We're dividing this by 5Q, and we're dividing this by 5Q. So 9Q squared minus what? Minus 4. Okay, now that's a difference, right? Subtraction, and these are perfect squares. What is your final answer going to look like? Don't forget the 5Q, right? Then you do your 2 binomials, one's plus, one's minus. 3q, and 2. So 3q plus 2 and 3q minus 2. And that is your final answer. I try to be really specific on the quizzes and the test and say, look for a GCF first. That doesn't mean there always is a GCF, but I try to remind you, like, hey, look for it. Maybe it's there, maybe it's not. But if it is there, make sure you take that out first and then do difference of squares. Okay. Okay. 2 more, but I want you to try them on your own first. So 25 and 27. Do those 2 on your own or with a neighbor. See what you get. If there's a GCF, take it out. And then do difference of squares. All right, anyone think they have an answer for 25? What's your GCF on 25? 6. You can factor out a 6. So when you do that, you end up with 4a squared and 9b squared. Okay, then you have to ask yourself, is that a difference of squares? And that's a perfect square, and that's a perfect square, and it is a difference. So it does work. So you go 6 times, one's going to be plus, one's going to be minus. What'd you get? 2a and 3b. Take the square root of both parts. 4a squared square rooted and 9b squared square rooted. So this is your answer. What'd you pull out of 27? What are 80 and 125 both divisible by? 5. Anything else that you factored out? Not 8. N squared. There's an n squared in both of those. So you end up with 80 divided by 5 and n squared divided by, n to the 4th divided by n squared. So that's 16 n squared, which is a perfect square, which is convenient. And then 125 divided by 5 n squared. So you get 25. N squared over n squared is 1. So it just looks like that. Are those perfect squares? So you're going to rewrite it. 5n squared times, one's going to be plus, one's going to be minus. Square root this, you get 4n. Square root this, you get 5. Okay? Any questions on that?